Particle effects can be used a number of different ways, from unpredictable fires to game juice, and if you're like me, making characters out of them to cover up the fact that you're bad at art. So in this tutorial, I'm going to teach you the basics of particles. All particle nodes do is emit particles, so we actually have to give it a material to tell it what particles we want it to emit. Once you give it a material, you should notice it emitting particles. If 8 particles per second isn't enough or is too much, you can change the particle node's amount property. If you wanted to make a particle effect that involves a sudden spray of particles, you should toggle the emitting property instead of hiding or deleting the node, as these methods will cause already spawned particles to disappear. Use the lifetime property of the particles node to change the length of time particles exist and scale the speed that material property curves and gradients affect them. If you want to move the particle node while it is emitting, for example, a torch that the player carries, you will want to turn local coordinates off. Otherwise, the particles will move with their node. Now let's look at the properties found in the particle material. Lifetime random randomizes a particle's lifetime by a given amount. Trail creates a pattern involving multiple particles based on the order that they spawn. The divisor is the amount of particles that make up a pattern before it will reset. The size and color modifiers affect the scale and color of the particles accordingly based on the particle's position in the pattern. The emission shape is the area where particles can spawn from. It can be a point, sphere, or box. Certain flags must be activated or disabled for certain properties to function. Direction only has an effect on particles when they have an initial velocity, and it's easiest to see without gravity. Direction requires a normalized vector, meaning all values in it must be less than or equal to 1, which also means that you cannot scale the velocity of a particle with this property. After setting the direction, you should see the particles move in the specified direction. You might also notice that some of them are slightly off. This is because the angle of spread is greater than 0. If you increase this value, you will notice the spread of particles begins to expand, and if you set it to 180, the particles will form a ball around the node, regardless of the direction. Gravity is, well, gravity. It will cause the particles to accelerate in the direction given. Keep in mind, however, that increasing the y value in 2D will cause the particles to fall, however in 3D it will cause them to shoot upward. Initial velocity will apply a set velocity to your particles. While it does work with gravity, it is easier to demonstrate the effect without. Angular velocity will cause particles to rotate at a certain speed. Keep in mind, however, that angular velocity will only work with disable Z or rotate Y. Orbital velocity will cause particles to orbit the center. Since our initial velocity is so low, we will have to use small values to avoid creating a small, dense, tight ball of particles. Linear acceleration causes particles to accelerate, well, linearly. Positive values of radial acceleration basically act like linear acceleration. However, with negative values, instead of damping, it pretty much creates central gravity. Tangential acceleration causes a particle to accelerate similar to orbital acceleration, while being unable to create a tiny ball. Damping basically adds friction to particles. Angle angles particles, and scale scales them. Color modulates particles, and color ramp can be used to control the opacity of particles and make them slowly fade out. Hue variation adds to the hue value of particles, and when using a curve, can make these rainbow particles. Animation can be used to do frame-by-frame particle animations. Pass the sprite sheet of the animation into the texture. Then, create a new canvas item material inside the material category. After that, in the animation property, set the H and V frames to fit your sprite sheet. Finally, turn on loop, set a speed, and watch your animation play out. Now, for some practice. Let's start out by creating a trail that follows the player's movement. First, we need to create the player. This player will be like the one used in my 2D movement and collisions tutorial, except without a collision shape. The first step is to add a particles material. So we can use the player sprite as a particle, drag it into the texture property. Since I scaled the player sprite, I'll do the same with the particle. In this case, we don't want the particles to be falling, so we need to disable gravity. To make the particles fade out, go to the color ramp property and add a gradient. This gradient only needs two colors, the first one being white, and the second one being white with no opacity. Finally, to draw the trail behind the player, enable Show Behind Parent. Success! Thank you for watching. Feel free to like and subscribe. If you have any questions, please leave them in the comments below.